Good morning, afternoon, evening, whenever you're doing this. This is our first lesson, our first video lesson in remote learning. So I'm sure Ms. Spear and Mr. Moore feel the same way, but we all miss you guys. You're going to be hearing me, Mr. Doherty, Mr. Moore, and Ms. Spear's voice as we go throughout this year, kind of doing the remote learning stuff. We're shouldering the brunt of the remote lessons, the videos for each other. We're each kind of taking a little bit and rotating through the weeks. So yeah, if you're in eighth grade math, you're going to hear all three of our voices. I was lucky enough to get the first week. So here we go. We're going to start talking about equations for week one. This is going to be 1.1. So if you're following along in the book or on Big Ideas Math or whatever you want to follow along with, we're going to be in 1.1. This is going to give you a very basic overview of what we're going to do with equations, what equations look like. It's not going to be anything that's really groundbreaking. You should already know this stuff from last year and from sixth grade even. This is more of a refresher to kind of get you in the mindset. We'll have a second video for 1.1 as well that'll go over one-step equations. So let's go ahead and get started. This page right here is going to be pretty much split in half. You may notice that the right side is the same as the left. That's because this is a half sheet. You're not going to do the entire thing. You're just going to use half of the sheet right here. So we're not going to look at the left. We're just going to focus on the right. You may also know that this is only one page. I'm going to have to be a little creative on how I get the second page up, but we're going to get that second page here, and we're going to do that as well. All you're going to need to do for this page is you're going to cut down this little line, cut up this little line as well. So you're going to have 4 flaps. After you get those flaps, you're going to kind of fold somewhere right there. And that fold is going to get it so that it covers the majority of the definition on the other side. You do not want to cover the equation, that 5x plus 4 equals 29. I'll post an example of that on my website. Mr. and Mr. Moore might do the same, but you don't want to cover that equation. You just want to cover the definitions there. And what you're going to do is you're going to take a pretty little marker or something if you have it, and you're going to go ahead and color your equation, little dealio, yellow. And look how beautiful this is. Oh man, hopefully yours will look better than mine. I can't really use the stylus on the screen very well. Hopefully it's easier on pencil and paper. We're going to cover equation yellow. Let's get a nice blue, more of a aquamarine maybe for variable. That's pretty. Coefficient, let's do green. That's not green. There we go. You can't even read that anymore, but that's okay. You'll be able to read yours. And constant, maybe like a orangey. Let's do more of an orange. That orange is good. All right. So you have those colored. They look all neon and cool on my page. Hopefully they look neon and cool on yours as well. So after you do that, you're going to flip it over, and I'm going to see if I can get the right thing. Aha, there we go. Okay, so this part is our back page. Okay, and again, let me find my brushes. There we go. We are not going to be using the left side because it's the same thing as the right side. So let me get those marks off. And here we go. We have this little equation on the right side. What we're going to do here is we're just going to get some definitions for equation, for variable, for coefficient, and for constant. That's all we're going to do. An equation, all it is 2 math expressions my beautiful handwriting, that are set equal to one another. Okay, so because I have terrible handwriting to begin with, and because the stylus makes it even harder on the screen, I'm going to read that out again. You can also pause and rewind if you didn't get it, but it's 2 math expressions that are set equal to one another. They have to have an equal sign. Write that down as well. It has an equals sign. Okay? A variable. A variable is going to be a symbol that represents an unknown number. I'm just going to use the little number sign there. Okay, so a symbol that represents an unknown number. For example, you could have X or Y or Z or W or M. Really, any letter. You can use any letter. Sometimes you see symbols or boxes. We're going to stop using those a lot once we get into more advanced math because it just gets a little confusing. But it's pretty much a placeholder. It's a symbol that represents an unknown number. Okay, a coefficient is the next one. And a coefficient is going to be a number used to multiply a variable. I'm going to try to zoom in. Not that much. Oh gosh, okay, that's not working. A coefficient there we go. Okay, coefficient is going to be a number used to multiply a variable. A number used to multiply a variable. Okay, so this would be, for example, like 5x would be equal to x times x times x times x times x. Okay, so again, beautiful handwriting, and everybody's super pumped about this. But yeah, you're just multiplying that x 5 times. And the last thing, a constant, is going to be a fixed value. Oh, okay, you're missing my E there, but a fixed value, it's just a number. So if you see a number off by itself, you have a constant. Okay, it's a fixed value or a number. Okay, last thing I want to do is I want to go ahead to this equation. You don't need to draw this arrow, but I just want to color in the things that we have. Okay, so we went ahead and did an equation as a yellow. Okay, so the equation here would be the entire thing. That's our equation. Our coefficient, dropping down to that, we colored green. So a coefficient, remember, is a number used to multiply a variable. The only number that's multiplying a variable is this 5 right here. Okay, so just color that 5 in green. Going up to the top right up here, our variable. We use this nice little aquamarine blue kind of thing. Our variable, a symbol that represents an unknown number. Our only unknown number is x. So this is the symbol that's representing an unknown number. And our last thing we have is our constant. And for constant, we use that nice little orange color. So we have a couple constants here. We just have numbers that are fixed values. So 4, 29. These are our two fixed values. And last but not least, just to explain what's going on here. This equation, okay, that we referenced at the beginning, this equation right here, what this means is 5 times some number, the unknown number, plus 4 equals 29. And your job when we get into the next lesson and throughout a lot of the year when we do expressions and equations is going to be to figure out what does this unknown number, what's the value of it? What value can I place in for x to make this statement true? Something times 5 plus 4 equals 29. We don't know what it is. We want to figure out what it is. All right, thanks for watching the first video, guys. Go ahead and hop on over to the second one. That'll be 1.1 day 2. Hey everybody, welcome back to technically what is day 2 of our notes. We're doing them all in one kind of asynchronous lesson because it's not too much information. But yeah, these are your second page of notes. And what we're going to be doing today is going over what really is 1.1, which is solving single-step equations. So you guys should have watched the first video already. If you haven't, on just parts of an equation, what an equation is, go back and watch that video first before you do this one. And make sure that note page is filled out and in your notebook. This one goes through, the first page looks like this. I'm zooming in a little bit, so I'm hoping that makes my handwriting look better. I don't think it will, but we're going to pretend like it will. So you should have the first page that looks like this. The left side should be blank. What we're going to do here is we're going to talk about how we solve those equations. So the last one we had was something like 5x plus 4 equals 29. I think that was it. And I told you that a lot of the equations, we're going to try to figure out what that variable, what that unknown value is. What can we plug in for x? What number can we plug in for x to make that statement true? There's a specific number we can plug in that will say 4 more than 5 times something should equal 29. We want to figure out what it is. So what we're going to have to do is, instead of just solving equations like normal, we're going to have to undo certain things that are in the equation. So we have 4 operations. There's a lot more than that in math, but the 4 basic operations that you can kind of boil everything down to are addition, subtraction, division, and multiplication. You guys should know what those are and be very comfortable with them by now. If you're not, go on Khan Academy, find some resources online, do some independent research, or reach out to your teacher, reach out to me, Mr. Moore, Ms. Spear, and we can give you some resources for that. Okay, but addition, what we're going to do to undo addition, if we have addition in a problem and we need to get rid of the addition, we're just going to do the opposite, or what's called the inverse operation. Okay, so remember, all these are called operations: addition, subtraction, multiplication, division. The inverse operation is going to be the opposite of whatever you're doing. So the opposite of addition, we're going to use addition, to undo. Let me get my marker set up. Subtraction. Okay. So if you have addition, if you have subtraction somewhere in your equation and you want to get rid of it, all you're going to do is add something to it. So think about if I take away $4 from you. How could I undo that? I could give you back $4. I could add $4 to your bank account, and then it would be like nothing ever happened. Okay, if I take away $4 and I give you $4, really that's a net zero gain or loss. You're not getting anything. You're not losing anything. You just have $0 extra dollars. Okay, subtraction. What we're going to do, we're going to use subtraction to undo its inverse operation, which, if you look up here, you should be able to figure it out, is going to be addition. Okay, so if you notice, we use addition to undo subtraction. We're going to use subtraction to undo addition. Okay, this is the inverse operations. From that, you can probably figure out these last two, and you did them last year, so you might remember as well. We're going to use division to undo multiplication. And we'll use multiplication. What color have I not used yet? Let's see, I've used blue, orange. Let's do a nice red. Multiplication to undo division. All right, so that's what your first page should look like. You have all of your inverse operations now. Addition, subtraction are inverse. Multiplication, division are inverse. Those are 2 sets of inverse operations that we're going to be focusing on for the first little bit. There's obviously a lot more inverse operations, We haven't talked about exponents, and we won't for a while. We haven't talked about a lot of different things, but those are the 4 basic ones that we're going to look at. Okay, so if we go through and we flip that page over, and so there we go. Okay, if we flip that page over, what we're going to do is we're going to talk about some properties of equality. I mentioned earlier taking money and giving it back. What you were left with was the same amount of money. It was equal. Or let's say you start out with $0. You earn 10 from mowing the lawn or babysitting or whatever you want to use for it. You earn $10. Then you spend that $10. What are you left with? $0. If you add $10 to your bank account and then subtract it, you're left at the same spot. Okay? Or if you had $100, you add 10, then take away 10, you're left with 0. Okay, so these properties of equality, let's see if I can get over there. There we go. Oops, actually, I'm doing the wrong thing there. 1 second. Here we are. So these properties of equality, pretty much what they do is they're going to give us an equivalent equation. Okay, so an equation that's going to be equal to the original one. Okay, so the addition property of equality, what it says is adding, oh, there we go. Adding the same number to each side of an equation produces an equivalent or equal equation. All right, so if we have this equation right here, 5 equals W minus 2, what we can do is we can add the same number to both sides of the equation. We can start off by splitting this equation right down the middle. And we can add the same number. Our number we're trying to find, the variable, our unknown, is our W right here. Okay, so this W is our unknown. Think about what are we doing to this W? What's being done to it? 2 is being subtracted from it. The opposite of subtracting 2 is adding 2. And whatever we do to one side of the equation, the right side, we have to do to the left to keep the equation balanced or equivalent. Okay? Subtracting 2 and adding 2 does what? It cancels out. So this minus 2 plus 2 turns into a 0. And we drop our W down here. So these 2's just kind of go away. Because minus 2 plus 2 is 0. Okay, you don't have to put that 0 anywhere in your equation. Then what we have over here is 5 plus 2 is 7. So 7 equals W. Let's go back to our original equation. If we plug in 7 for W, is 7 minus 2 equal 5? If it does, then we did it correct, and it should. Okay, the other side over here. Again, we can split this equation. Right on the equal side, we have a left side and a right side. And what we're doing to the x is we're subtracting 7. The opposite of subtracting 7 is adding 7. Whatever we do to one side, we have to do to the other. Minus 7 plus 7 cancels out. All we're left with on the left is x. So we can bring that down. Bring our equal sign down. And negative 6 plus 7 is positive 1. Okay, Okay, -6 plus 7 is +1. If you forgot how to subtract or add your negative numbers, that's a really important skill, as well as multiplying and dividing them. Get some resources on that. Go to Khan Academy. Reach out to your teacher. We can help you out with that. The next one is the subtraction property of equality. The subtraction property of equality is going to be really similar to the addition property of equality, but all it'll say is subtracting the same number on each side of an equation produces an equivalent equation. Okay, so subtracting the same number on each side of an equation produces an equivalent equation. All right. So if we look at this over here, we can do the same exact thing. Split our equation in half. We have a left side over here and a right side. We're adding something to our variable. To get rid of addition, the inverse operation is subtraction. So all we have to do is subtract 2 from both sides. Once we do that, 2 minus 2 is going to be 0. Those cancel out. Our variable gets brought down. And 9 minus 2 equals 7. So that's our answer. And think about it. 7, if we plug that in for y, because they're equal, they have the same value, 7 plus 2 does equal 9. So we know we're right. All right. Next one over here. X plus 8 equals -12. What are we doing to our variable? We're adding 8. The opposite of adding 8, subtracting 8. We have to do it to both sides to make sure that the equations are equivalent. 8 minus 8 cancels out to 0. All we're left with on the left side is x equals -12 minus 8, which would be -20. All right. We're going to go down to the division property of equality. What the division property of equality says is dividing the same number to each side of an equation produces an equivalent equation. I'm sure you guys are seeing a pattern here. All right, there we go. So we look at our equation over here. 6x equals 18. We have a left side and a right side. This one looks a little different because there's no addition or subtraction signs like we had up top here. There's only a number and a variable. If you remember from last year and the last video we talked about, this 6 is going to be our coefficient. That's the number we're multiplying by the variable. So whenever you have a number next to a variable, that's multiplication. That's what's happening there. Okay, so 6 times x equals 18. The opposite of multiplying is going to be dividing. So we would just divide both sides by 6. This fraction bar that I'm putting in right here is a division sign. A fraction bar and a division sign are the same thing. This is just a little bit of shorthand. Instead of actually drawing out the division sign, it gets a little messy if you do that. I think keeping things straight up and down makes it a lot easier. Okay, so 6x divided by 6 will just give you 1x. Think about if you have $6, you divide them equally among 6 people. Each person gets $1. So we're left with 1x on the left. 18 divided by 6 equals 3. X equals 3. We can check that by plugging it back into the original equation. So we take that 3. You don't need to draw that arrow. But if you take that 3 and plug it into the x right there, 6 times 3 does equal 18. All right, next one. 21 equals 3 times w. Same exact thing we're going to do here. We're multiplying w times 3. That's what's being done to it. We have to do the opposite or the inverse. So we're going to divide by 3. 3w divided by 3 we do something to one side, we have to do it to the other to keep the equation equivalent. 3 W's divided by 3 would just give us 1 W. 21 divided by 3, 7. So W is equal to 7. Again, if we plug that 7 in to the W, 3 times 7 does equal 21. So we know we got it right. And last one down here, multiplication. I think I used a red for that. If I didn't, you can change it up. But multiplication, multiplication property of equality just says multiplying the same number to each side of an equation produces an equivalent equation. All right, so on this side, if we look at this equation over here, you can first of all divide it in half, get a left side and a right side. What's being done to x here? It's being divided by 7. The opposite of dividing by 7 is multiplying by 7. So we can multiply both sides by 7 and keep an equivalent equation, or expression, excuse me, or equation, actually, right? So we can keep an equivalent equation if we multiply both sides by 7. Okay. If I divide something by 7, then multiply it by 7, those two are going to cancel out. All I'm left with is x equals -4 times 7. A negative times a positive, remember, is a negative every time. And 4 times 7 will be 28. So -28. X would equal -28. If we plug that into our original equation, -28 divided by 7 is -4. So we know we're correct. And last one, divide that equation in 2. Think about what's being done to the variable. W is being divided by 5. Okay, so we're dividing by 5. The opposite of dividing by 5 is going to be, one second. There we go. Multiplying by 5. Whatever we do to one side of the equation, we have to do to the other. W divided by 5 times 5. Those 5s cancel out because they're inverse operations. 5 times 11, or sorry, we pull our W down. That's what's left on the right. 5 times 11 is 55. W equals 55. We can check it by plugging in our 55 for our W because they should be equal. 55 divided by 5 is 11. So we were correct on that. All right, those are all your notes for the first week. I appreciate you guys' time. Let us know, let your teacher know if you have any questions on these. We're more than happy to give you some additional resources. And I hope you have a good week, and we'll talk to you soon.